We're going to do an example in this video using the precise definition of a limit. We're going to find the limit value, and specifically we are going to determine my delta, my horizontal error, given epsilon, my vertical error. So this problem says for the given function f of x and the given values of c and some positive epsilon, we need to find the limit L, the limit of the function as x approaches c, and then we are going to determine the largest value of a positive delta such that the precise definition of a limit, these conditions are met. Okay, so for part A, the first thing we need to do here, we need to find the limit as x approaches 9, 9 being my c value, of my function f of x, which this is the same as writing the limit as x approaches 9 of 27 over x. So in this case, if I want to find the limit, I can simply evaluate it, and that gives me 27 over 9, or 3. So 3 equals my limit value, L. So x approaching c, c being 9, that's going to give me my limit value of L. That portion of the problem should be relatively easy. So now we get to our new part, which is using that definition of a limit. And I'm just going to come over here and say, okay, well, we know that this limit in the situation is 3. So if we are given this epsilon value, we need to determine delta. So what we're going to do is we're going to start with our epsilon part of the definition, and we are going to derive delta. So my epsilon portion of the definition, I have f of x, which is 27 over x, minus L, my 3 value, needs to be less than or equal to 0.7. So we need to solve this. We need to determine what my x value should be. So here we're going to work to solve this inequality. So I put 0.7 is less than 27 over x minus 3 is less than 0.7. I would add 3 to both sides of my inequality, or to all sides, plus 3, plus 3, plus 3. And I'm going to write my answer as a fraction, not a decimal. So 0.7 is 7/10, and that might help us if we went ahead and changed that right here. If I've got negative 7/10 and positive 7/10. So 7/10 plus 3, which is 30/10, that gives me 37 over 10. And on the other side, 30/10 minus 7/10, that gives me 23 over 10. So I'm left with 27 over x in the middle here. So I have two inequalities for which I need to solve. You can see that. So I'm going to solve each one separately. So my first piece, I have 23. 23 over 10 is less than 27 over x. If we cross multiply here, I have 23x is less than 270, or rather x is less than 270 divided by 23. Similarly, on the other side, I have 27 over x is less than 37 over 10. Again, we cross multiply. I have 270 is less than 37x. Divide by 37, 270 over 37 is less than x, and that's the same as writing x is greater than 270 over 37. Now, both of these fractions, they don't mean a lot to us in fraction form. So for the sake of considering our distances, we are going to look at them as decimals, even though we're going to keep them as fractions in our calculations. So I'm going to write that here. We have x needs to be less than 270 over 23 is approximately 11.74. And 270 over 37, that says x needs to be greater than 7.30. 297 rounds to 30. All right, so what we're looking at and what we're trying to determine is what my delta range is going to be. Now, my x value is approaching 9, c being 9. So this is 9. We're looking the fact that x has to be less than 270 over 23, which is approximately 11.74, or x has to be greater than 270 over 37, which is approximately 7.30. All right, so what we want is the smallest interval. So we need to look at the value or the space, the difference between these two in each of the situations. And that is found merely by doing some subtraction. So we're going to choose the smallest possible delta. In this case, delta might be 9 minus 270 over 37. And my other situation, my delta could be 270 over 23 minus 9. We take the larger minus the smaller. So performing each of these subtractions, I have a delta over here on the left equals 63 over 37, which is approximately 1.7027, and my delta on the right is 63 over 23. And that delta value is approximately 2.739. So it's easy for us to see which delta value is smaller, 63 over 37. So we choose delta. Our answer here is we're going to choose our delta value to be 9 minus 270 over 37. And if I choose that, then that's going to truncate. It's going to cut a little bit of space off on the other side of my interval. But that's the smallest possible delta. So if I choose any value between less than 9 or greater than 9, that is 270 divided by 37 less than or greater than, my answer will always fall within my prescribed epsilon range of the limit. So my answer is going to be within 7/10 of my limit 3. And let's just think about that on our graph. So if we consider the graph of this function, it's a hyperbolic curve, does something like this. And say we have some point at x equals 9, because we are looking at approaching 9 from either the left or the right. So we're saying, well, as we get closer from the left and right towards this value, what is my output? And the output is my limit 3. And so what this problem says, well, if I want to ensure that my limit is within this range, 3 plus 0.7 and 3 minus 0.7, within 7/10 of 3, as long as my delta is less than this value we found on the bottom here, 9 minus 270 over 37. All right, so we can be 9 minus 270 over 37 on that side, or over here, that would be 9 plus 270 over 37. So adding that value. And I hope at this point you have a better understanding of this precise definition of a limit. Remember, we are just We're given our vertical prescribed error, and we are trying to determine what our horizontal error is allowed to be so that I will always fall within that epsilon range.